Okay, here's the worksheet from today. This is Monday, October 8th. Okay, so this is graphing rational expressions. This is activity 13, review. Okay, so the first one says 4x plus 5 over x plus 1. Neither the top nor bottom can be factored. So you're going to look at this to answer these questions. Since there are no common factors, there is no whole. Okay, so the discontinuity is not a whole, it's a vertical asymptote. To get your vertical asymptote, you look at your denominator. Set this equal to 0. So your vertical asymptote is x equals -1. So you're going to come over here to the graph, and you're going to draw a vertical asymptote at -1, all the way down. All right, the horizontal, I'm going to go down here. The horizontal asymptote, by the way, there is no slant asymptote because the degree in the top is the same as the degree in the bottom. So the only way there's a slant is that the degree in the top is bigger than the one in the bottom. Since these are the same, the horizontal asymptote, you would take the 4x divided by x, which is 4, because the x's cancel. So the x's cancel. So it's 4 over 1, which is 4. You divide the leading coefficients, which is really y equals 4 divided by 1, which is 4. So we're going to come here at 4, and we're going to draw a horizontal asymptote at 4. So now that we have our asymptotes in, now we can answer the question, what is the y-intercept? The y-intercept, you're going to let x equal 0. So it'd be 0 plus 5 over 0 plus 1, which is y equals 5. Okay, so 5, 1, 2, 3, 4, 5. So that is 1 point on your graph. Since that is over 1 to the right and up 1, right and up, we're going to go left and down 1. So there's a point right there on the other curve. The x-intercept, we're going to let y equal 0. But when we do this and we cross multiply, you end up just setting the numerator equal to 0. So that's what I usually do anyway. Subtract 5, divide by 4. So x is -5/4. So that's -1.25, which is about right there. So that's enough points for me to draw a curve. I only need 2. Now you're allowed to punch this in the calculator to get other points, but at this point right here, it would be left 1/4, down 4. So if we go right 1/4 and up 4, we should get a point right there. And if you really want other points on your curve, you can look at the t-table to get them. And that's it. That's number 1. So number 2. So this problem right here, x squared plus x, I'm going to factor the top. And what do you notice? You should notice that these x1s cancel. So that's called a removable discontinuity. So what's left is just x. So the rest of the problem is going to be off of that. But before we can do that, we have to take care of the hole in the problem. So there's no vertical asymptotes because there's nothing left in the bottom, but there is a hole. So you take that common removable discontinuity and you set that equal to 0 and solve. So x -1 is not the vertical asymptote, it's the x-coordinate of the hole. And if you want to know what the y is, you just plug it right into x. So the y-coordinate looks like it's -1, -1. So it looks like about right there. -1's pretty far away, but then this goes by 2's, so it's about halfway down. That's the hole. That's going to be worth 3 points. There is no vertical asymptote because this is all that's left. So all the rest of the questions come from here. So there is no horizontal asymptote and no slant asymptote because all you have is x. What is y equals x? It's a line, right? So like, what is the y-intercept? Let's let x equal 0. Let x equal 0. So if you let, so basically if you're letting x equal 0, it looks like this. So that means y equals 0. So that's a y-intercept. To find your x-intercept, you're going to let y equals 0. That's all of this. So x equals 0. So the y-intercept and the x-intercept are both 0, 0. This is just a line. If you write it like this, what that means is that your slope is 1 and your y-intercept is 0. So you're going to go up 1. This is I can't tell these numbers. Going by 2's. So think of this as 2 over 2. So go up 2 over 2. Down 2 over 2. So that should put you right on the line. It's all these points except this thing right there is a hole. There is a hole right there. Make sure it looks like a hole. I just kind of darken that, so I need my white out because I just colored in my hole, so I gotta make that look like a hole. I'll just white it out. That's a hole. There's a hole there. Okay, next. Since the degree of the numerator is greater than the degree of the denominator, there are no horizontal asymptotes, okay? Perform polynomial synthetic division to find the asymptote. Remember to eliminate. You don't have to do that in this problem because once you eliminated this, it was gone. So I'm not even going to make you do this. I changed the problem. That's why there isn't one, so don't worry about that. What is the equation of the asymptote? There isn't one. I guess if you would have went off my original problem, there would have been one, but don't worry about this. So forget all those questions, x, because I changed the problem. Okay, next. Oh, you can't read these numbers. Can you read them? Oh, I think this is a 3. I apologize. These are 3's. This is a cube, and this is a square. Oh, I'm sorry, guys. That's what it should look like. All right. So I'm going to factor the top. Take an x squared out, and you're left with x plus 1. Take a negative 3 out, and you're left with x plus 1, which is x plus 1 times x squared minus 3. All of this is over x plus 1. So we are going to remove this one and this one, and you're left with f of x equals x squared minus 3. So the whole is, you take the x plus 1 over here and set it equal to 0. So this is not a vertical asymptote. It is the x-coordinate of the whole. Yes. Thank you. Think you did all right?
Yeah.
Okay. So when you plug the negative 1 into this, you get 1 minus 3, which is negative 2. So I'm going to put that right here. So the whole is at negative 1, negative 2, which is right there. You see that? Negative 1, negative 2. That's the whole. Now this one's kind of like the one on the top, the front. Once you remove these factors, you were left with this. The one on the front was a line. What is this? This is a parabola or quadratic. It should be U-shaped. There's no denominator left, right? So there's no vertical asymptote. I already crossed that out. There's actually no horizontal or slant asymptote either because there's no fraction left. So there's only asymptotes if there's a fraction. So no asymptotes when this is just a regular expression, no fraction. So we're going to answer our other questions. What's the y-intercept? To get the y-intercept, we're going to let x equal 0. So y equals negative 3. So y equals negative 3 means on my graph that it should be going through negative 3. That's the y-intercept. X-intercept, you're going to let y equal 0. Looks like that. X squared minus 3 equals 0. So add 3 to the other side. Square root both sides. So x is plus or minus square root of 3, which is about 1.7, plus or minus 1.7. So on the graph, you want to go about 1.7 and negative 1.7. And the rest of this, you can just punch in your calculator. Now, if you punch in the original, you're going to get, let's see, fraction alpha, y equals fraction. All right, so we're going to have x to the third plus x squared minus 3x minus 3 over x plus 1. Okay, we are going to graph zoom 6. I said there was a hole, right? -1, -2. Can you see one at hole there? Can't really see that. So you know what I'm going to do? I'm going to press zoom 4. Oh, do you see the hole there now? Do you see the hole? Isn't that exciting? Look, there's a hole there. I see the hole. Okay, isn't that beautiful? Aren't you guys excited that you can actually see the hole? So -1, -2. So if I just want some more points on the graph, I would go to my t-table. Hopefully it's, oh my God, look how ugly this t-table is. To make your t-table pretty, press second window, start at 0, go by ones, and let's get some pretty points by pressing second graph. So I see a 0, -3. There's that y-intercept. 1, -2. I see that. Look at that. Symmetric to the hole right there on our graph. I see 2, 1. I don't have that one yet. There's 2, 1. 3, 6. Might as well graph some pretty points, right? And then I'm going to go to the negative side. So I see a -3, 6. I see a -2, 1. I think I've got plenty of points to draw this beautiful looking quadratic with a hole in it. Look at that. Isn't that lovely? And again, the graph looks just like it with a hole in it. Now, when you go to the graph, oops, go to y equals and go to y2 and just type in this thing right here. This, let me go back over here. See this x squared minus 3? If you type that in, x squared minus 3, and you press graph, it's the same graph because it is the same. Oh, look, it went red. But what did it do? It closed in the hole. It's like fix the hole. It's like you're a roof contractor. You just fixed the hole in the roof. Okay, because we removed that hole. So now it shouldn't be there anymore. So that means we should be able to go to the t-table and find what that hole is. Do you see where the error is? It was -1 error, that's the hole, but now we know what the y is. It's -1, -2. And that was what we said our hole was. -1, -2. All right, I'm moving on. Hope you guys understood that. So the next problem, there's lots of factoring that can be done here. So we have 2x plus 4, and we have x minus 6 and x plus 4. We have another removable continuity here. So this time, the hole is going to be -4 something. So let's remove it and write down our new fraction. This is what's left. So if you plug -4 in right there, you would get 2 over -10, which is -1/5. So that is where your hole is. -4, -1/5. So I'm going to plot that. -4, -1/5 is really small right there. You see it? So now there is vertical asymptote. So this one, because of the x squared, means that you have two discontinuities. One of them was the hole, and the other one is the vertical asymptote. So the vertical asymptote is x equals, so go to this thing right here. Look at the denominator. What makes that 0? Should be 6. Just a second, my husband's calling. Sorry. Hello? Yes. I'm doing a video right now. Can I call you back in a second? All right, bye. All right, so we're going to draw this vertical asymptote at x equals 6. I'm doing it with red. Okay. I'm not sure if you can see what I'm doing there. I did a vertical asymptote. Can you guys see this? You might not be able to see this. That's the vertical asymptote, and there's a hole. These are your two discontinuities. So if you would graph this on your calculator, which I will do, I know it takes forever, but if you go to alpha y equals, you get a fraction. Oops, I'm typing this in the wrong thing, but that's okay. 2x plus 8, and the bottom is x squared minus 2, oops, that was plus, minus 2x. Do you know that if you type in a negative accidentally instead of a subtraction, it'll graph wrong? So make sure your subtractions are subtractions and not negative signs. It could throw your whole graph off if you type a negative in versus a subtraction. Anyway, let's see what this graph looks like. Oops, you know what? I'm going to press on. Let's press zoom 6 so we get the general thing. You're not going to see the hole, but it's there. And that curve's going all the way to that vertical asymptote of 6. You see it over there? That's what it should look like. Does it look like it's all centered around that vertical asymptote of 6? Everything, you can see everything except the hole. So if you wanted to see the hole, press zoom 4. Remember, it was -4, -1/5. You see the little hole right there? I'm going to try to see. Oops. Can you see it? At -4. Look at -4. There's a little hole there. You can also see from looking at the t-table that there is an error at -4, which is the vertical asymptote. And the, the -4 was the hole. The 6 was the vertical asymptote. Let's keep going to 6. There's 6, error. Okay, there's 2 errors. So anyway, those are your discontinuities. Now, horizontal asymptote. Whenever the numerator, so looking at this right here, whenever the degree, which in this case is x to the 0, because there is no degree, is smaller than the one on the bottom, it's always y equals 0 for your horizontal asymptote. It's always y equals 0. So you should come over here and draw a horizontal asymptote through the x-axis. That means there is no slant. There's only a slant asymptote. God, this is so big. Wait a minute. There's only a slant asymptote if the degree in the top is bigger than the one on the bottom, which is not the case. So there is no slant asymptote. Now, y-intercept. Let x equal 0. Now, you're letting x equal 0 in this problem right here. So if you let x equal 0, you get this, which is 2 over -6, which is -1/3. That's your y-intercept. So right here, at 0, -1/3 is right there. It's going through that point. And then we're going to solve for our x-intercepts, which there is no x-intercept because that's not an x. Okay, so there's no x-intercept, so put none. So we've answered all of our questions. We just need some t-table points, and I've already got this graph. So let's look back at our t-table. Let's look some numbers past 6. So I see 7, 2, and 8, 1. Those are great points right there. See them? 7, 2, and 8, 1. Those are nice, easy points. So 7, 2, and 8, 1 are nice points on the curve. I'm good enough grabbing that right now. So look at points around 6. So look at 5. If you look at 5, it's -2, and 4 is -1. So 5, -2, 4, -1. And these are good points for this curve. Now, not only do I have these two, but I have this one and this one, this hole. So jump over the hole, hit the y-intercept, hit those 2 points I just graphed, go down by the asymptote, and you're done graphing. Okay, so number 5 is x minus 2 over x minus 3 and x plus 1. Okay, so nothing cancels on this one. So there is no hole. That means there are 2 vertical asymptotes. One is x equals 3 and one is x equals -1 because I'm looking at the denominator. So for these ones that have double verticals, get the vertical asymptotes. So you should have 2 errors, and they're both going to be right here. It's really hard to see these, so I gotta make them nice and dark. Okay, those are your vertical asymptotes. Now, let's go down to the horizontal. What's the horizontal asymptote? Look at the beginning. Do you see how this is smaller than this? That means it's automatically y equals 0. Since this is smaller than this, there is no slant asymptote. So we can go ahead. Now, there's 2 kinds of ways this graph can go. You can have a curve here and a curve here, a curve here and a curve here, or it can be like a parabola here. If you ever have something like here and here, I think you're going to have, I don't know, I have to look. We'll have to look to see what the points are. It depends what the y-intercepts and x-intercepts are. Y-intercept, let x equal 0. So you can do it from the original problem or the new problem. I like the original problem, to tell you the truth. So 0 minus 2 over 0 minus 3. So basically the y-intercept is 2/3. So 2/3 is about right here. That's your y-intercept. X-intercept, you're going to let y equal 0. Which basically means set your numerator equals 0, because when I cross multiply, it's going to be 0 equals x minus 2, and x equals 2. Now, it might seem like that's weird that you had this horizontal asymptote, meaning that the curve's not supposed to touch it. But on the 3 curve parts, one case is the middle one can sometimes go through the asymptote. And I believe this one is. It's going to be like a snake. It's going to be like this. It's going to hit this one. It's going to come down. Now, if you just treat it like this is the first asymptote right here, like if you cover it up this one, if you have a curve right here, then you should have another curve down here. If you cover up this half, if you have a curve here, you should have another curve up here. But we can get that get the rest of the points by graphing it on the calculator. Okay, so this one is x minus 2 on the top, x minus 2, and x squared minus 2x minus 3. Okay, we're going to graph. Remember your asymptotes were at -1 and 3. Does that look like that's happening? Okay, so we need some points. We need some points to the left of -1 on your t-table. Just find some nice points. Find some points to the left of -1. For example, any one of these, like -5, -4. None of them are nice, but I like -2 and -4/5. -2 and -4/5 is about right there. And I like -4 and -2/7. That's even smaller. So these are not going to go over the asymptote, but they're going to come right wrong side of it, and you're going to go like that. So since they're so close, I'm just going to go ahead and draw this one and be done. Looks like that. Boom. Next. Now we have the inequality ones. Yay. We do not have to graph these. We just have to do a number line for these. So for this one, let's think of this in its factored form. All right, let's do a number line. First step, find all restrictions. Restrictions are discontinuities. Okay, so you're going to set x plus 4 equal to 0, and you're going to set x plus 2 equal to 0. So x equals -4 and x equals -2. These are going to be open circles because if it was -4, this would be 0. If it was -2, this would be 0, and you're not allowed to divide by 0. So these are called discontinuities. So you plot those, -4 and -2. And they're open circles, meaning they can never be those numbers. It can never, ever, ever be those numbers. Then the second thing you're going to do is find the zeros. You do this by setting your numerator equal to 0. You can set the whole thing equal to 0 and cross multiply. But since it's 0, you just set the numerator equal to 0, and your 0 is -6. Now, on the zeros, you have to decide. Should it be an open or closed? This depends on the original inequality. Since it is greater than or equal, we want closed. So -6 is going to be a closed circle. So we basically have 3 sections. We have the part that's less than -6, the part between it, part between this, and everything greater than -2. So we're going to do a test point. You can test -7, -5, -3, -1, 0, 1, 2. I'm going to test 0. So 0 covers this entire section over here. This entire section. This is not an open circle. Sorry. I don't know why I circled that. Don't circle that. This is not a circle. This is not a circle. Test 0. So basically, when you test a 0, it looks like this. If you put a 0 in, is it greater than 0? Let's see. This is 6 over 8. Is that greater than or equal to 0? Well, yes. It's positive, so it's greater than 0. So 0 does work. Thank goodness I can shade this in. So this whole section works. That means this section does not work. That means this section does work. And that means this one does not work. So your answer should be -6 bracket to -4 in union with -2, that's parenthesis, to infinity, parenthesis. The only one that's a bracket is the 0. 6 was a 0. Do you want me to graph this to show you? Alpha y equals x plus 6, x squared plus 6x plus 8. Graph. So they wanted to know when this whole rational function is greater than 0. That means above the x-axis. So do you see where it's above the x-axis? Both of these curves right here are above the x-axis. This one right here is below. So when is it above? Well, it has something to do with these -6s and -4s. See where the -6 is? -6 is a 0. So you see where it crosses at -6 right there? It's crossing at -6. So it is above. Let me go to zoom 6 for a second. It's actually below. I don't know if you can tell. It's below the x-axis, but it starts crossing over at -6. 2, 3, 4, 5. At -6, it crosses at -6, and then it goes above. So from -6 to the asymptote, -4. From -6 to the asymptote, -4, it's above 0. Then between the asymptote -4 and the asymptote -2, it's all below 0 or less than 0. And then when does it go back above 0? After the asymptote -2, it hits above 0, and it looks like it stays above 0 the whole time. So hopefully that makes sense. So our answer was between -6 and -4. From -6 to -4, it's above. Not here, but then again, starting at -4 to infinity. Or no, sorry. At the asymptote -2 to infinity, it stays above 0. All right, let me close that off. So this one, let's get a number line ready. Start by doing your restrictions first. So this one's x minus 3, x minus 2. So your restrictions, set your denominators equal to 0. Solve. And these are open circles at 3 and 2. Step 2, find your zeros. In other words, set your numerator equal to 0. X equals -3. So at -3, we're going to do a closed circle on -3 because there's an equal sign. So we have 4 sections again. So like this is 2.5. Test 0. So if you test a 0 and up here, it'd be 0, 0, 0. You end up with 3, 6. Is 1/2 less than or equal to 0? No, it is not. So this section does not work. That means this section does. So -infinity to -3 bracket in union with 2 to 3. This one does not work. And this is your answer. It's the every other section. The 0 did not work. So that means this one did, and this one did, and this one didn't. Now the next one is greater than 2. The first two were to 0. This one's 2, so this one's slightly different. You can still do your restriction the same way. Your restriction is -2, and that's an open circle. Okay, the restriction doesn't change. It's an open circle at -2. The 0 does change. The 0, we're going to set this expression equal to 2, and we're solving for x. We're solving for the 0. So we're going to cross multiply. And x equals 0. This is an open circle because the original inequality is just greater than. So we have 3 sections. 3 sections. So what number do you want to plug in? I'm going to plug in a 1. I'm plugging in 1 from way over here. So if I plug in a 1, I'm asking, is 4/3 greater than 2? The answer to that is no. That's 1 1/3. So 1 doesn't work. That means this one does. That means this one doesn't. So your answer is -2 to 0. So if you want to graph this and see, you should have, the curve should be above the 2 at this point. Should we do it or no? No. All right. Backside. I didn't ask you what to do on this problem, so I think I want you to graph this. Maybe describe what's happening. I'm going to say that you're going 4 right and 2 up. Your asymptotes are moving. Your asymptotes are moving. X equals 4 because of that being 4 right and 2 up. There's your asymptotes. So, let's see. Let's just graph it. Alpha y equals, we got 1 divided by x minus 4, and then we got plus 2. So you want to get some points around this asymptote of 4. So look at your t-table and find the error sign first of all. All right, there's the error sign. Give me some numbers around the error sign, like 3, 1. 5, 3. 6, 5 halves, so 6 and 2 1/2. And 2 and 1 1/2. So one thing I might want to know is what the x-intercept is. So if you see a 0 anywhere, you kind of want that number. I don't see a 0 though. Like the y-intercept. So if I said what is the x-intercept, you would let y equals 0. So if I was letting y equals 0 in this problem, I'd have this. Would you be able to solve this if I let y equals 0? Subtract 2. Cross multiply. Subtract 8, divide by 2. So 7 halves and 0. That's 3 1/2. So it looks like it on my graph. I almost got it. It's right here. 3 1/2 is the x-intercept. So I'd want to make sure that's going through 3 1/2. How can you solve for the y-intercept? You let x equal 0. So that'd be y equals -1/4 plus 2, which is what? 1 3/4. So 1 3/4 is about right here. Make sure that it's going through the y-intercept. So those are a little bit trickier. All right, write the equation of the horizontal and vertical asymptotes. Well, I'm going to graph this. I'm going to factor this, Take an x out. All right, first of all, we're removing this. Okay, so that's not that's not a horizontal or vertical asymptote. So now that these are gone, now that's a hole in the graph, but I didn't ask for a hole. I did not ask for a hole. Just write the equations of the vertical and horizontal asymptotes. So the vertical asymptotes would be x equals 0 because of this one, and x equals 4 because of this one. There's your vertical asymptotes. Your horizontal asymptote is not the numerator. It is the comparison of the original graph. This was an x squared, and this was an x cubed. Because this is one smaller, it's y equals 0. No work needed. And this last one, for the function, what does g of x approach as x approaches the -4? So if you were graphing this, you would have a vertical asymptote at -4 and one at 4. Okay? I would quickly graph this if I was you. So type in -x divided by x squared minus 16. Here's your graph. Okay, so just try to get this to look like this. So we have okay, so it looks like this, okay? So the question is, what does this function approach as x approaches -4? This is as x approaches -4 from the left. That's what this negative means. From the left. So put your curve in here. Put your pencil right here. As the curve approaches -4, this is -4 right here. This is the -4 asymptote. So as the curve approaches -4 from the left, what does the end do? This end right here. You would say the end goes to positive infinity. And that's it. And the next last problem is write the equation in factored form. Let's see how we can do in this problem. Let's start with the fraction. Let's start first with the vertical asymptote. What is it? You see how that's x equals -1? So that means I have a factor of x plus 1 in the bottom. That's from the vertical asymptote. Now this whole is 2, 1. It is 2, 1. But all that means to me is I have a factor of x minus 2 up here and here because of the whole being at 2. Now this is going to get a little tricky when I try to find this, what that missing number is. What's the horizontal asymptote? It is y equals 2. So I need at least a 2 up front here and a 1 here. And I need to have the same number of factors top and bottom. So I need another factor here. Oh, what is this going to be? I have an x-intercept of x plus 1, right? Do you see that one right there? So that means I have an x minus 1 factor in the top. I have a factor of x minus 1 top because I have an x-intercept of 1. So there's that. And then this one is a y-intercept of -3. Means if I FOIL all this out, oh gosh, this is a hard problem. I'm so sorry. This is a really hard problem. So let's FOIL this out for a second. This is -3x plus 2. I have a 2 out front for 2x squared minus 6x plus 4. On the bottom, I have an x squared. What is it? Minus x minus 2. I have a y-intercept of -3. So somehow I got to get this to be a -3. Oh gosh. Right now it's a -2. Maybe I should just redraw this. Let's just change it and make it easier. We'll change that y-intercept to a -2. That'll make it nice and easy. I was making this up anyway. So we'll say the y-intercept is -2. So do you see that right there? The y-intercept is -2. If you divide, we can't see that. The y-intercept is -2 if you divide. I FOILed everything out. The horizontal asymptote is y equals 2 because these are the same. The factors of x minus 1 means that you have it goes through the 1. This cancels, so you should not be going through 2, but that is a whole 2 something, and the whole should be 2, 1. Hopefully that works out. If I plug a 2 in, let me see. If I plug a 2 into this, that'd be 1, that'd be 2, and that would be 3. We'll just say that hole's a little bit lower. Hey, I'm just making this up as I go. And I'm going to be satisfied with this problem right here. Don't cross these x minus 2's out. I was just giving you an idea of how to do something like that. We'll practice that later on Wednesday. All right. I was making that problem up, so I had to change a few things as I went. All right, guys, I'm done. I'm sorry. 38 minutes later. Apologize. Love you.